Hi, I'm George Woodbury from College of the Sequoias in Visalia, California. And in this video, I'm going to go over applications of linear equations, which is just a sneaky way to say word problems. We're going to go over a few different types, finding an unknown number, some geometry problems, problems involving consecutive integers, motion, and coin problems. Okay, let's get started. In general, the strategy is as follows. We derive this from George Polya, P-O-L-Y-A. Let me write that for you. Who wrote a great book titled simply How to Solve It. And this strategy is based on his strategy. First, read the problem. You read it once real quickly to get a rough idea of what type of problem it is. You read it a second time very closely to extract all the important information. List all the important information that you have. Step 2, you need to come up with a variable for an unknown quantity. That's step 3. Sometimes we build up other unknown quantities in terms of that variable. At this point in the course, we'll be using just one variable. We need to come up with an equation that relates the known quantities to the unknown quantities. We'll solve the equation, and then we check our solution, not just mathematically, but also to make sure that it makes sense. So the best way to get started here is to run through several different types of problems, and we'll begin with an unknown number problem. This is basically a translation issue. It says 7 less than twice a number is 33, find the number. Okay, so in this problem, we only have one unknown, and it's called the number. Now we need to choose a variable for that, and I'm going to use x. You could use n for number if you'd like. But now we need to translate that first sentence into an equation. So as I'm reading, I'm going to start off with is 33. That is shorthand for is equal to 33. So I know that my equation is going to end with something equal to 33. Now as I start to read the rest, 7 less than tells me to subtract 7 from something. Twice a number, well, again, if our number is x, then twice a number will be 2 times x. So our equation is going to be 2x minus 7 equals 33. Add 7 to both sides. Gets us to 2x equals 40. Divide both sides by 2, and that gets us to x equals 20. So the number is 20. Now let's go back and check to make sure this makes sense. Twice a number is 40, so 7 less than that is 33. Everything works out. Let's take a look at an unknown number problem that has a little bit more to it. This one has 2 unknown numbers, and I can tell that right away from the first sentence. One number is 9 more than another. And I'm going to use that to get started here. I'm going to build a table of unknowns, and here I have 2 unknowns, so I'll call them number 1 and number 2. And I'm going to let x represent the first one. We'll always have one of our unknown quantities being represented by a plain variable like x. Now 2x or x minus 2, one of them will always be x. Now we're told that one number is 9 more than another. 9 more than means to add 9, so I can let the second unknown be represented by x plus 9. When I read the second sentence, I see a reference to a smaller number and a larger number. And I need to know which of these two is the smaller and which is the larger. Well, adding 9 makes the number larger, so the first number is the smaller number, and the second one is the larger number. Now I'm ready to translate that second sentence into an equation. It says that 3 times the smaller number is added to 2 times the larger number, and the sum is, or equals, 153. All I have to do at this point is substitute variable expressions for my smaller and larger number, and I'll have my equation. In place of the smaller number, I'm going to put in x because that was my smaller number. In place of the larger number, I'm going to put in x plus 9 because that was my larger number. And again, this is equal to 153. Now to solve, I'll begin by distributing the 2. So I get 3x plus 2x. 2 times 9 is 18. Combine like terms. 5x plus 18 equals 153. Subtract 18 on both sides. 5x equals 153 minus 18 is 135. Divide both sides by 5, and I have x equals 27. Okay. If I said find the numbers and you came back to me and said x equals 27, you haven't answered my question. I need to take that solution back to the table of unknowns and substitute 27 for each x. Well, the first number is just x, so that's going to be 27. But the larger number was x plus 9, so that's 27 plus 9, or 36. Our two numbers are 27 and 36. I'll leave the check to you. For geometry problems, I'm going to focus on perimeter of a rectangle. But there are lots of other ones that you may have to use, like perimeter of a triangle, complementary angles add up to 90, supplementary angles add up to 180, circumference of a circle, etc. Your textbook will have a list of the formulas that you'll need to use, so check for that. For the perimeter of a rectangle, we need to know that the formula 2 times the length plus 2 times the width is equal to the perimeter. If we draw a rectangle, the length is the longer side, the width is the shorter side, and the perimeter is the distance around the outside. So as we add our way around, we have 2 of the lengths and 2 of the widths. Let's use this in a problem. The length of a rectangle is 1 inch more than 3 times the width. The perimeter of the rectangle is 138 inches. Find the length and width. Okay, so in this problem, our unknowns will be the length of the rectangle and the width. And once I come up with variable expressions for those two, it's going to be 2 times the length plus 2 times the width equals the perimeter. Okay, as I read the first sentence, I'm given the length in terms of the width. In such a situation, we want to go ahead and let the one we know the least about, the width, be the plain variable. You can't see me, but I'm using air quotes around plain variable. I'm going to let the width be represented by W. I could use x again, but at the end of the problem, when I come up with a solution like W equals 5, I know that 5 is the width. Then I can just come back and figure out the length. Okay. I need a variable expression for the length, and I see that it's 1 inch more than, that tells me to add 1. 1 inch more than what? 3 times the width. And that's going to be 3W. Okay. So when I plug in here, 2 times the quantity, 3W plus 1, plus 2 times W, I'm told that that's equal to the perimeter, which is 138 inches. Distribute, just like we did in the last problem, right? 2 times 3W is 6W, plus 2 times 1 is 2, plus 2W equals 138. Combine like terms. I'm running short on room here, so I'm going to go ahead and say the step without actually showing it. I need to subtract 2 next. 138 minus 2 is 136. and I divide both sides by 8, and I'm left with W equals 17. I'm going to take the solution to that equation and come back to my table of unknowns so I can figure out the length and the width. The easy one is the width. That's simply W, so that's 17. The length, I put in 17 for W, so that's 3 times 17 plus 1, which works out to be 52. So we say that the length is 52 inches and the width is 17 inches. 52 is 1 more than 3 times 17, and if we take twice the length and twice the width, we'll find that it adds up to be 138 inches. Another important type of problem involves consecutive integers. Consecutive integers are integers that are in a row, like 3, 4, 5, and 6. When we build the table of unknowns for consecutive integers, we're going to let the first one be represented by x. The second one is going to be represented by x plus 1. And here's the reason why. To get from the first number to the second, we can do that by adding 1. For the next integer, we add another 1, which will be x plus 2. The fourth one will be x plus 3, and so on. However many you need. Some problems have 2, some have 17. You just have to keep writing them down however many you happen to have. Okay. Now some of the problems, rather than saying consecutive integers, we'll say consecutive even integers. And that works a little differently. Let's take a look at some consecutive even integers. 8, 10, 12, 14, and so on. We begin by letting the first number be x. But when it's time for the second of those integers, how far is it from an even integer to the next even integer? Well, we can see that it's 2 higher, so we'll use x plus 2. To get to the third one, we'll add another 2, which is x plus 4. The next would be x plus 6, and so on. X plus 8, x plus 10, x plus 12, etc. Finally, some problems involve consecutive odd integers. And we have to know how to set up our unknowns for those. And the first one will be x. Any idea what the second one will be? Well, if you're like a lot of students, you might guess x plus 1, x plus 3, x plus 5, but that actually isn't correct. Take a look at consecutive odd integers. To go from one odd integer to the next one, all we have to do is add 2. So if we compare the even and the odd, we notice that the setup is the same. That's because even numbers are spaced 2 units apart, and odd integers are spaced 2 units apart. So the setup will always be the same if you're told that they're consecutive odd or consecutive even. Now, if you know that they're only consecutive, we go up in steps of 1. If they're odd or even, we go up in steps of 2. Let's try a couple of problems to demonstrate this. The sum of 3 consecutive integers is 195. Find the 3 integers. So I'm going to put my unknowns here. Let the first one be x, and I know that I have a total of 3 integers. Got a little ahead of myself there. Are these just odds or just evens? We're not told that. We're only told that they're consecutive integers. If they were supposed to be odd, that would have been mentioned right here. So since they're consecutive integers, they go up in steps of 1. And my 3 unknowns are x, x plus 1, and x plus 2. We're told that their sum is 195. So the sum would be the first one, x, plus the second one, x plus 1, plus the third one, x plus 2, is equal to 195. First step for solving this is to combine the like terms. X plus x plus x is 3x. 1 plus 2 is 3. And that is all equal to 195. Now notice, if you're only looking for the sum, I could have summed them here. 1, 2, 3x. 1, 2 is 3. And gone right to my equation there. Subtract 3 from both sides. 3x equals 192. Divide both sides by 3, and we end up with x equals 64. So our three numbers are going to be 64, one more than that, 65, and one more than that, 66. Let's take a look at one more consecutive integer problem. This one deals with the sum of 4 consecutive odd integers. And when I see that, a little siren goes off in my head. I know that instead of going up in steps of 1, I'm going to go up in steps of 2. There are 4 unknowns. And so those are the two things I look for first. How many are there, and are they special, odd, or even, or are they just consecutive? I always let the first one be represented by x, and then because these are odd, I'm going to go up in steps of 2. I'm going to use that trick I showed you on the last problem. I'm going to find the sum right here. Right? The problem involves the sum, so I can total these together. I have 4x plus 2 plus 4 plus 6 is 12. So my equation is going to be 4x plus 12 equals 192. Subtract 12. 4x equals 180. Divide by 4. And I get x equals 45. Come back to the table. The first one is 45. The second is 47. 2 more than that. Another 2 gives me 49, and 2 more gives me 51. So the 3 odd integers are 45, 47, 49, and 51. Motion problems involve this equation. R times t equals d. R stands for the rate, the speed. T stands for time in the same units as the rate is given in terms of miles per hour and hours, feet per second and seconds, etc. And d is the distance traveled. Here's one of my favorites. George started to drive towards Las Vegas at 70 miles per hour. They changed drivers, and Tina drove the rest of the way at 80 miles per hour. Tina drove 1 hour more than George did. If the trip to Las Vegas was 380 miles, how long did George drive for, and how long did Tina drive for? Okay, I'm going to build a little table. First, I'm going to list the driver, George and Tina. And I'm going to list the rate for each, the time for each, and the distance for each here. And we're going to have to figure out where our equation is going to come from, but let's start picking off information. George drove at 70 miles per hour. Tina drove at 80 miles per hour, so that is her rate. Now, we don't know the time, but we do know that Tina drove 1 hour more than George did. So whatever George's time is, and I'm going to use t for time, Tina's time was 1 more than that, t plus 1. Remember, in the formula, rate times time is equal to distance. So George's distance, 70 times t, is 70t. And Tina's distance, will be 80 times the quantity t plus 1. Now I do know the total distance was 380 miles. So George's distance plus Tina's distance will have to add up to be 380 miles. Sometimes you're given the time as the unknown, like the total time, and you can work backwards in that fashion. But our equation is going to be here underneath distance. So let's go ahead and continue that on the next page. 70t plus 80 times t plus 1 equals 380. Okay. Distribute. 80 times t is 80t. And 80 times 1 is just 80. Okay. Combine like terms. And subtract 80 from both sides. If you're brave, you could do both of those steps at the same time. We're left with 150t equals 300. Divide by 150 on both sides of the equation, and we find that t is equal to 2. Okay. So I'm going to go back a page and let's take a look at that table again. The question asks, how long did George drive for and how long did Tina drive for? The times for those two were t for George and t plus 1 for Tina. So if George's time was t, that equals 2 hours. And for Tina, that was t plus 1. That's going to be 2 plus 1, or 3 hours. So George drove for 2 hours, Tina for 3. All right, on to the last problem for this video. This is an example of what I call a coin problem. A coin jar contains nickels and dimes. We have 7 more nickels than dimes. The coins are worth a total of $2.60. How many nickels and how many dimes are in the jar? Okay, I'm going to collect my information in a table again. I have N for nickels and D for dimes. I'm going to have one column that represents the number of each coin. I'm going to have a second column that represents the value of each coin, and then finally a column that represents how much money we have for each type of coin. To find the amount of money in each coin, all we have to do is multiply the number of coins by the value of each coin. Okay, let's go pick off the important information. For starters, we know the value of a nickel and a dime. A nickel is worth 5 cents or 0.05, and a dime is worth 10 cents or 0.10. The second sentence will help us figure out how to write the number of each coin in terms of one variable. There are 7 more nickels than dimes. So I'm going to let the number of dimes be D, my plain variable. There are 7 more nickels, so that's going to be D plus 7. And again, to figure out how much money I have in each coin, I multiply the number by the value to get the amount of money. So for nickels, that's going to be 0.05 times D plus 7. And for dimes, that's going to be 0.10 times D. Now here I know the total value is $2.60. So my equation is going to be the sum of the amount of money in nickels and the amount of money in dimes. That has to be the total. All right, let's set up that equation on the next page. 0.05 times D plus 7 plus 0.10 times D equals $2.60. Now I want to make sure I copied that right, so all I have to do, let me go back a screen and let me just compare that again. 0.05 times D plus 7 is there. 0.10 times D is there. And the total was 260, and that was there. You'd be surprised how many students make a mistake miscopying information from the problem. It's tough to get it right if you don't start with the right information. To solve this, I distribute the 0.05, gives me 0.05 D plus 0.35 I'm sorry, plus 0.10d equals 2.60. Combine the like terms, 0.05 and 0.10 add up to be 0.15d plus 0.35 equals 2.60. Subtract the 0.35 on both sides, and I have 0.15d equals 2.25. Now, if you've made a mistake in the setup, it will often show up at the next step. When I go to divide both sides by 0.15, if I don't get a whole number, I've got a problem because I can't have 3.7 dimes for instance. So if you after this step you end up with a decimal or fraction value, something's gone wrong and you want to go back and check, did I set it up right? Did I make a mistake along the way? Here, 2.25 divided by 0.15 using a calculator is equal to 15. Now recall from the other page, the number of dimes was D plus 7, so that's going to be 15 plus 7, or 22 nickels. And the number of dimes, well, that was just D, so that's going to be 15 dimes. Okay, when I compare these, I have 7 more nickels than dimes, that works, and 22 nickels is worth $1.10. 15 dimes is worth $1.50, and that totals to be $2.60. If you're in my online class, the suggested homework for this section is 1 through 8, the vocabulary questions. I've got a bunch of odds for you to try, 9 through 19, 41 to 47, 55 to 59, 61 to 65, and 67 through 69. And I also want you to add problem 37 into that mix. If you have any questions or comments on this video, or if you've got a request for a video that I can put together for you on YouTube, you can reach me through the contact page on my website, and the address there is georgewoodbury.com. Thanks for watching and good luck with these word problems.